Hello guys, so welcome you all. So today we are back with a very new topic of differential equations, how to solve with differential equations, how to calculate with the solutions and what actually are called differential equations. So whenever, for example, if I say that my dy by dx is equal to 1, so what do I mean with that? That is differentiation of any function of y with respect to x is giving me the answer of 1. So how do I know with that? So this solves with my differential equations, that is how to come back with the original equation of my differentiation and how to form an equation out of the derived equation. So that is how we call it as an equation that contains derivative of department variables. In the basic bookish language we say department variables, wherein we call it as x and y. These are called our departmental variables, and also we say them in basics as a differential equation. So how do we work with that? For example, if I am given a differential equation, I'll be telling you how to solve with different types of differential equation. I am just telling you a simple method that how do we know that equation is a differential equation. For example, if I am given dy by dx as a function of x comma y. Okay, so now whenever I know that a function will be in form of x and y both, and where I write that my y is equal to, for example, 4x. Okay, so how do I form a differential equation, or how do I write with my differential equation? For example, question says that form a differential equation of degree, suppose 1. So now I use the word degree. Okay, and I will also use the word order. So what do I mean with both of them? First of all, I'll explain you how to solve the equation on the later part. First I'll tell you what does order mean, and then I'll explain you with degree also. Order of an equation basically is the highest order of the derivative that is occurring in the differential equation. That is, for example, if I say that my dy by dx to the power 2 plus d2y by dx square is equal to 1. For example, this is my equation. So here this is my order because I am double derivating it, and this is with the value 2. That is, I have differentiated my function 2 times. So I say that my order of the function is 2. And coming on with degree, if I am saying degree means the highest power of the highest order. That is, if I say the order 2 function is having degree 1, highest differentiation that I made is with degree order 2, and the power of this order is 1. So I am using my degree will be 1 of order 2. Okay, so just remember, order is something different, not equal to degree. Degree is the power of differentiation that we are using here. Okay, so that is very much different. Okay, so now I'll be discussing with the forms of equation and how do we solve them. Okay, so every different form of equation has different formats to solve them up. So I'll be discussing with each and every. First of all, going with separable equation. So what do I understand by separable equation? It's very much clear that I can separate my equations in different forms. For example, I am taking again with the question of dy by dx of f x comma y. That is, I am having a function wherein I am having x as well as y. So how do I separate it? For example, fx is in the form of fx and dx. Now I can separate this function in fx as well as gy. That is two functions I can make, fx and as well as fy. So now what I did is I took this dx here and is equal to, I'll take that my gy is into dy. Okay, so I can separate this equation. For example, I'm taking just a simple equation dy by dx equal to x by y. So what I can do is, now I can easily separate this equation by writing dy into y, which is equal to dx into x. Now what I'll do is, I integrate on both the sides to have my actual equation, that what was my actual equation. So this becomes my solution. When I'll solve this up, I'll get my solution back. Okay, so this is our example of separable equation and how to solve them. I have done it here. Next type of equation, that is homogeneous equation. How to solve with homogeneous equation, I'll also write up with one example so that you can get a better idea of how to go on with the question. Okay, so homogeneous equations is said by like whenever, for example, if I say my dy by dx is equal to f of xy and divided by g of xy. Okay, so I will, when my functions are identical, I will use that they are homogeneous in nature. You can just see that my function is of fx and gx are both homogeneous function. Why? Because x and y are having same degree. Okay, and both of them are in the form of, where I can say dy by dx is equal to f of y comma x, for example, and the other one is also of gy by x. So both of the functions are same, just I am using different variables. Okay, so herein I say that my function are homogeneous and I will solve them. I'll solve my both the equations. But what I will do is, I will substitute the value of y as vx. Okay, when I'm going for homogeneous equations, we put in the value of y as vx. Okay, to vary how to get that equation is actually homogeneous, you will put y equal to vx, and similarly you will do it in gx also. And then what happens is, you will receive v as common and they will cancel out each other, so you will get same function. And if you receive same function again back to the pavilion, so that will be your homogeneous function. Okay, just remember that you can verify that your equation is homogeneous or not by putting y equal to vx, and if your function returns to the pavilion, then your answer, your equation is homogeneous equation. And then how to solve with that equation, I'll just solve it in short. For example, then later on what you will do is, you will also substitute like first I what I'll do is, I'll solve with this first, and then so that you can have a with actual equation how to solve them up. Step 1 is, put y is equal to vx. Okay, and then just differentiate the function. That is, you will receive dy by dx equal to v plus x into dv by dx. Okay, you will receive it when you will differentiate it. Now you will take another function wherein you will be putting x equal to vy, and then you will differentiate this with respect to y. So you will get dx by dy, which is equal to v plus y dv by dy. Okay, so now you can just see that your functions are actually identical to both of them, and you can solve your equation by separating them. So you are getting similar type of equations, so these equations are homogeneous equations. Okay, so coming up with next type of equation, we say them as linear differential equations. Why we are talking saying linear, the word linear itself tell us that we are only working up with the one variable. Okay, or like we are working with a linear type of equations. These type of equations are in the form of like dy by dx, and then there will be plus or minus into py, which will be equal to a constant of q. Okay, so p and q both will be constants, and you will only have x in this linear equation. So whenever you solve with these type of equations, you know that okay, this is my linear equation, but understand this has a different type of formula to solve in, because you will have to find integrating factor here. Okay, so what is integrating factor? Now to calculate with integrating factor, what we do is we take exponent, and then we take integration sign in the power, and then take p, and then differentiate with like integrated with dx. So this will be your integrating factor here. Okay, so now uh, the this type of equation becomes your linear type of equation, and at the end whenever you are working with the solution, how to solve with the solution, you'll receive x. You just need to work with integrating factor and the equation. I'll tell you how to put on with the equation. Okay, so x into integrating factor, that is if. You will easily be able to solve with this question, how to work with this, and then taking up with equal to sign and taking integration, and then q is this constant, and then again multiplied by integrating factor that you have calculated here, and then take up with dy. Okay, so this becomes my equation. This is my final equation. At the end I'll receive this kind of equation. You just need to put on with the values that you are receiving here. Okay, so that will be your answer, and how to solve with the equation. Now coming up, if you are having a differential equation wherein you are having x as a here variable instead of y. Okay, so how that type of equation will look, I'll just tell you with that also, so that you have both types of equation in your mind. uh, Now dx by dy. Okay, whenever your equation is with respect to y, you will have here the variables will be x. You will not have y because you are already differentiating it. So you will have px, which will be equal to q. Again, p and q will be constant, and so that's all with the types of differential equations. We only have these three types of differential equations. Whenever you are required to solve with the questions, you will always be working with these types of equations only. Okay, so now for example, I'll just take up a few questions and make you identify how these equations look like. For example, if my equation is dy by dx plus cos y, which is equal to 0. Now you can just see here that this is my now you can just see here that this is my separable equation. Why? Because my dy by dx is separate and my cos y is separate. So I can just separate my equation very easily. Alright. Now coming up with next type of equation, I'll just have one more type of equation so that you have a idea. Now if I say that my equation is dy by dx, okay, plus y into cos of x equal to sin x. Okay, so this is my linear type of equation. By now just see here that you are having y multiplied by cos x and is equal to cos x. Now see, you are differentiating with respect to x. So just remember that this type of equation is said to be a linear type of equation, or else I'll solve you with I'll show you with another type of equation also, all these type of equations. Okay, I'll also tell you whenever how to get that okay, this is my linear type of equation. If you are able to find up, or if you are able to identify that okay, I need to find here integrating factor, so that becomes your linear type of equation. For example, x square into dy by dx, uh, adding up with y, which is equal to x to the power 4. Now you can see here that you are having dy by dx, and you are having one variable of y separate to x. So uh, we can very easily identify that okay, this is my linear type of equation. So this type of equation is again my linear type equation. Now whenever I need to calculate with any homogeneous type of equation, just with this you can easily identify that okay, this is my uh, linear equation, and this type of equation is my homogeneous equation, and this type of equation is my separable equation. You just need to crack down that what kind of equation is present in front of me, and you need to solve it up. Okay, so going up with linear type of equation, you can just identify that okay, if I'm able to solve its integrating factor, if you are able to know that okay, I am having this equation in the form of by dx plus p y is equal to q. So your equation will be linear type of equation. So you just need to identify that okay, this is my this type of equation, and you will be good to go. Another type of now these are very easy type of questions that are mostly asked in 3 to 4 marker questions, but when you are talking in terms of 5 marker questions, you have questions like verify uh, the equation given below. For example, I'll just show you a type of question that we mostly have in with us. For example, just look here, equation given to you is a square plus x square bracket close into d2y by dx square, adding up with dy by dx equal to 0. So you need to verify this equation, and you are given y is equal to log of x plus root into x square plus a square. So what you will do is you will find out when you need to verify these type of questions. Okay, there are two type of questions, either verify or show that. Okay, in verify questions you will just differentiate it once, put its value here, then you will differentiate it again and put its value here, and you will solve this. If you receive 0, then your question is verified. But if your question is show that, then for example, I'll just show you an example of show that type question. Question says show that your y is equal to a into cos of log x. Okay, and then adding up with b sine log x. Okay, so here you have to show, what you have to show, that x square d square y by dx square plus x into dy by dx is equal to 0. So here, sorry, there is another variable, plus y is equal to 0. So what you are given this, first you will differentiate this once. Okay, then you will receive some equation, and then you will differentiate it again, and at last you will not put your equation here, you will rearrange this equation and make it according to this, and definitely you will have an equation form of this type at the last. Okay, you will also receive similar this type of equation at last again. So you will put it equal to y, and then you will receive this type of equation at the end. So in show that questions, you have to take up with y value and differentiate it according to the question. If your equation says 2 times differentiation, then differentiate it 2 times and then rearrange it, you will receive this type of equation, absolutely correct. But there are another type of question wherein you have to verify it. So just differentiate it according to question and put in the equation, you will get answer equal to RHS. Okay, so these type of questions are there in 5 mark questions and they are very easy to score. So just don't think to skip those questions, just do them and practice a lot. You will score 5 on 5 marks in these type of questions. Thank you very much guys. Meet you in next class.